Hi, my name is Kwan Liu, and this is my Physics 2 Lab 5 presentation. The objective of this lab is to determine the time it takes for a magnet to fall through an aluminum foil tube using two methods: experimental measurements and coding model. So with the experimental method, we're going to drop it through the tube 5 times and record the times, and with coding, we're going to use a coding model to predict the drop time. The key principles we're using are Faraday's law for calculating magnetic flux, Newton's third law to understand opposing forces in the system, and Ohm's law to understand how voltage relates to the resistance and the current. Here's a result preview, and we see that the experimental drop is actually much higher than the coding drop because of experimental error. So we also are going to use magnetic force on a wire, which is used to calculate the magnetic forces acting on the magnet through Lenz's law and Faraday's law. So the system is the magnet in the foil tube, and the surroundings are everything else. And the initial conditions are that the magnet's dropped from rest and it falls through the tube vertically. Here's our experimental data with an average drop time of 1.55 seconds. And here's the code. So the geometry of the tube included variables such as length, width, and radius. The properties of the magnet included the magnetic dipole moment. And we used these numbers to find to define some functions, and we use these functions to find this. And here's the velocity over time. You see it goes down and then it comes back up, but it peaks, or it plateaus at a certain velocity, which could be called the terminal velocity. So the experimental drop time was 1.55 seconds, whereas the program drop time was 1.18 seconds. And potential errors might have been that the magnet tumbled, or the tube wasn't made with, or it was imperfect, and it wasn't held by an apparatus, so there could have been some human error in that the tube wasn't vertical enough, or that it caused some tumbling. So what if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? The magnetic force would increase by extension, so the magnet would just take longer to fall through the tube. And what if holes or slots were cut into the tube? How would that affect the ring's current in my model? Cutting holes or slots in the tube would reduce induced currents and magnetic force, allowing the magnet to fall faster. But if there is a long slit cut into the side, which would break the circular flow of current, then the tube would cease to prevent any magnet falling at all. This lab has enhanced our understanding of magnetism and factors including a magnet's fall through a conductor tube. Thank you for listening.